welcome to our education channel, and we are continuing to look at the techniques of differentiation. And the second one we are going to look at is the quotient rule. So this quotient rule will help us to differentiate functions which have been divided. Like we have function y is equals to x plus 1 divided by x plus 2. So there we shall now apply quotient rule to differentiate such functions. So before we use it, let's first derive it. We shall say suppose u and v are functions of x such that we have our function y is given by u over v. But remember, this u over v, I can also write it as u is equals to, y is equals to u v to power negative 1. Reason being, when this v goes up, it will get inverse or its inverse, which will become negative 1, since here it is power 1. Then it will lead us in our product rule. So we shall apply product rule to differentiate this. It means our dy dx is given by, first of all, we shall have u times d dx, or the derivative of v power negative 1, then plus v to power negative 1 times du dx. So if you didn't watch our video about product rule, you can check in the link below. You can watch how to use or how the product rule was derived. So from here, we shall see that this part here, we shall apply a little bit of chain rule here, whereby we have our d of the derivative of v to power negative 1 dx will be the same as, when we differentiate this, we shall have what? Negative v to power 2 negative 2 dv shall have this dx. So it means instead of the whole of this shall now be equals to this. So if I substitute, I will have this to be, we shall have it to be u times negative v to power negative 2 dv dx plus v to power negative 1 du dx. Now what we are going to do here, we shall take this we shall make them positive by getting their reciprocal, or their reciprocal. So it means our function here will become now negative u dv dx, but this one is over divided by what? By v squared. Then allow me to put this cosine here, plus this will remain du dx over v. Now when we get the LCM of these two, we shall see that we are going to have the whole of our LCM is v squared. So the whole of this v squared divided by v squared is 1 times negative u dv dx will give us negative u dv dx. Then plus v squared divided by v, we shall have v. Then v times du dx will give us v du dx. So what does this mean? We can start with the one which is positive. So we shall see that our dy dx is going to become v du dx, then minus u dv dx, everything over v squared. So this will now be our quotient rule. Now what does it mean? It means that when you are having a function y is equals to u over v, when you are finding the derivative, you will keep v constant, differentiate u, then you subtract, keep u constant, then differentiate v, then divide everything by what? By v squared. And here, take care of what is negative. So don't make, when you're keeping this, ensure that it is the negative is on when you're keeping the first function constant or the numerator constant and you're differentiating the denominator of dv dx. So we shall look at one example under this, then we see how this rule is applied. Thank you for following us and subscribing. You can watch the second video.